You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we begin our journey into the foundational concepts of computing. You'll learn what computing means in the context of information technology, how it relates to everyday devices, and why it plays a central role in the CompTIA IT exam. This episode lays the groundwork for understanding logic, processing, and systems concepts that will appear again and again across later domains. By starting here, you build a mental model that supports topics in data, hardware, programming, and more. Whether you're completely new to tech or revisiting the basics, this overview will give you the clarity and terminology needed to progress with confidence. Computing is one of the first topics introduced in the ITF Plus objectives, and for good reason. It sets the vocabulary and structure for how technology works. Understanding computing early allows you to recognize how devices complete tasks, solve problems, and follow instructions. This knowledge forms the core of everything in IT, from hardware and networks to programming and databases. Computing connects users to systems and systems to logic. It's how tasks are automated, how data is processed, and how results are produced across all platforms. Let's begin with a simple definition. Computing refers to the process of solving problems and handling data through the use of technology. It involves using both hardware and software to input, manipulate, store, and output information. From a smartphone calculating your daily steps to a server processing thousands of online requests, computing is at work. Nearly every modern electronic device contains some form of computing power, even if it's not obvious at first glance. Whether the goal is to calculate, control, display, or analyze, the process of computing underlies it all. At the heart of computing are four basic system functions: input, processing, output, and storage. Every computing system, from a desktop to a digital watch, follows this core model. Input refers to data coming into the system, such as a keyboard press or a sensor reading. Processing is the work done inside the system, typically by a central processing unit. Output is the result that's sent out to the user or another system, like a displayed image or a printed document. Storage keeps information for later use, whether it's temporary in memory or long-term in a drive. So what exactly makes a system a computer? For the purposes of the ITF Plus exam, a computer is any device that can receive input, process data, store information, and produce output based on programmable instructions. It must be capable of logical decision-making and able to run software or code. This includes not only traditional desktops and laptops, but also servers, smartphones, tablets, and smart appliances. A computer can be general purpose, meaning it can perform many tasks, or embedded, meaning it performs a specific task within a larger machine. Examples of computing devices are all around us. Traditional personal computers, smartphones, and tablets are obvious examples, but gaming consoles, smart TVs, smart home devices, and point-of-sale terminals are also computing systems. Servers that host websites or manage databases are some of the most powerful types. Even embedded systems in appliances, industrial machinery, and medical devices perform computing tasks, though their interfaces and capabilities vary. All these systems share core components and rely on logic, memory, and processing to perform their functions. Understanding the word system is essential here. A system is more than a single piece of hardware. It's a group of components working together. In computing, a system includes both hardware and software. It may be a single computer running an operating system, or it may be a network of devices interacting with shared data. A system can be as simple as a standalone calculator or as complex as a distributed cloud architecture. What defines a system is not size or appearance, but the coordination of parts working toward a common goal. One of the most important components in any system is the operating system. This is the software that manages the interaction between hardware and applications. It provides the user interface, manages tasks, allocates resources, and coordinates processes. Whether it's Windows, Mac OS, Android, or Linux, every operating system plays the same essential role. Without an operating system, a computing device would not be usable for most tasks. It provides structure and control over how the system performs work and responds to user commands. System logic refers to the way a computer follows instructions and makes decisions. All logic in computing is based on rules that evaluate true or false conditions. A simple logical rule might be, if the user presses the button, then turn on the light. More complex logic can involve comparing values, performing calculations, or looping through steps until a condition is met. Logic is what enables systems to follow instructions predictably and consistently, even for tasks as complex as image recognition or financial analysis. Behind every logical operation is an algorithm. An algorithm is a defined set of steps used to complete a specific task. Algorithms can be simple, like adding two numbers, or complex, like sorting large datasets. They are used in programming, automation, analysis, and nearly every other IT function. When a user sends a print job, the system runs an algorithm to manage the queue. When a smartphone unlocks using facial recognition, it uses an algorithm to analyze visual data. Understanding algorithms prepares you to grasp how systems function under the surface. Instructions in computing are the building blocks of behavior. Instructions are written in software, interpreted by the processor, and executed in a fixed order. Each instruction tells the computer to perform a specific operation, such as moving data, performing math, or checking a condition. The Central Processing Unit, or CPU, handles this execution. It fetches each instruction, decodes it, and carries it out, often billions of times per second. The logical structure of these instructions ensures that systems operate in a reliable and predictable manner. It's also important to understand that computing happens across platforms. Phones, tablets, laptops, and smart appliances all process data in similar ways, even though their interfaces and use cases are different. A smart speaker interprets voice commands the same way a phone processes a keyboard input by receiving data, processing it, and producing output. The differences lie in the scale, purpose, and performance level, but the core computing principles remain the same, whether it's a smartwatch or a server farm. Computing is no longer confined to desktop computers or data centers. It is embedded in everyday objects, from wearable fitness trackers to cars and refrigerators. The ability to compute is what makes these objects smart. By processing input and generating useful output, they become interactive, adaptive, and sometimes autonomous. Understanding this embedded computing helps you grasp why the ITF Plus exam emphasizes computing early. It is no longer just a specialized function. It is a part of daily life, work, and every modern profession. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. As computing systems evolved, so did their ability to interact with the real world. Sensors, actuators, and input-output peripherals allow computers to take in external data and produce physical responses. For example, a temperature sensor provides input to a system that might activate a fan or sound an alarm if a threshold is exceeded. These types of interactions illustrate how computing is applied not just in virtual environments, but also in real-world control systems. This integration of logic, data, and physical response is central to fields like automation, robotics, and embedded development. Another way to understand computing is to explore the difference between software and hardware roles in a system. Hardware includes the physical components, things you can touch, like keyboards, monitors, and processors. Software consists of the instructions and data that tell the hardware what to do. A system works only when these two elements communicate properly. The processor executes instructions stored in memory, often through operating systems and applications, while input and output devices serve as the bridge between the user and the system's inner workings. Understanding binary logic is also fundamental to computing. At its core, every computing system relies on binary values, ones and zeros, to represent all data and instructions. These binary digits or bits are used in logical operations, stored in memory, and transmitted across systems. Binary is not just a number system, it is a language. All logical conditions, from simple comparisons to complex algorithms, are ultimately expressed in binary. This is why the ITF Plus exam includes sections on number systems, units of measure, and data representation, all of which tie into binary logic. Computing systems are also defined by their scalability. A system might begin as a single desktop but grow into a multi-node network, or even a distributed cloud platform. The principles of computing remain consistent even as the scale changes. Whether you are managing a standalone device or a globally distributed application, the system still requires input, processing, storage, and output. This scalability is a reason why basic computing knowledge applies equally to home networks, enterprise systems, and cloud-hosted services. The ITF Plus exam introduces the concept of computing not only to describe systems but to prepare learners for deeper domains. Many of the terms used in Domain 1 reappear in Domains 2 through 6. For example, understanding how data flows through a system supports troubleshooting, database use, and software evaluation. Learning what a system is prepares you to recognize what can go wrong and how it can be secured. These connections are what make computing an essential starting point for all technical learning. In many real-world settings, computing happens invisibly. Systems handle tasks automatically in the background, without direct user interaction. Background processes manage memory, network activity, security protocols, and software updates. Understanding that computing continues even when a user is idle helps you grasp the complexity of systems management. This knowledge is useful when preparing for questions that deal with performance, automation, or background services. User interfaces are another important part of computing systems. A user interface allows people to interact with machines through screens, keyboards, voice, or touch. Graphical user interfaces, or GUIs, make complex systems accessible through icons and windows. Command line interfaces allow direct instruction through typed commands. Voice interfaces use speech recognition to accept spoken input. While the interface may differ, the underlying computing process is the same. Input is processed, logic is followed, and output is returned. Connectivity has expanded what computing means in modern environments. Today's systems are rarely isolated. Devices sync data across cloud platforms, share resources on networks, and update software remotely. Computing is no longer confined to a single machine. It extends to entire ecosystems of devices and services. This concept is essential for understanding mobile computing, the Internet of Things, and cloud-based applications, all of which rely on shared computing processes across multiple systems. Security is also tied closely to computing. Because systems process data, they must be protected against unauthorized access, tampering, or failure. Logical access controls, encryption, and secure input validation are all examples of computing processes applied to security. When you study cybersecurity later in the ITF Plus domains, you'll see how logic, algorithms, and system behavior intersect with protection and risk management. Security is not a separate layer. It is a design principle embedded in the logic of modern computing. The evolution of computing has introduced new paradigms like virtualization and cloud computing. Virtual systems simulate physical devices and allow multiple environments to run on the same hardware. Cloud computing allows processing and storage to happen on remote servers instead of local machines. These are still computing processes, but they shift where and how the computation occurs. Understanding that these models still follow the same input-process-output logic helps demystify what seems like advanced technology. Learning about computing also helps you think like a technician or problem solver. If you understand how systems are supposed to behave, you're better equipped to recognize when something goes wrong. You can identify whether an issue lies in the input, the logic, or the output. This mindset is essential not only for support roles but for programming, system administration, and database management. Thinking in terms of computing flow prepares you for practical tasks you may face in future roles or certifications. The concept of abstraction is also key in computing. Abstraction allows users to interact with complex systems without needing to understand every internal detail. For instance, clicking a save icon abstracts away the processes of writing to storage, validating input, and confirming file type. This simplification allows people to use systems without mastering code or hardware. As a learner, understanding abstraction helps you recognize what's happening behind the scenes without needing to be an engineer. To close out this episode, remember that computing is not a single action. It is a continuous process. Every time you input data, run a program, receive output, or store a file, you are engaging in computing. From the smallest embedded system to the largest data center, the logic and structure remain the same. By understanding these core principles now, you create a strong foundation for every other topic in your ITF Plus journey. Logic, systems, flow, and decision-making are not only topics for one domain, they are the thread that connects them all. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.